How do hackers hack phones? Let's get straight to the point. Here we have Leo operating a Kali Linux machine and Katie using her phone. Leo is performing an authorized penetration test against Katie and is about to break into her phone. Let's see how. Leo is going to start up the Metasploit console. Metasploit is an exploitation framework used in penetration testing. He is going to select a Metasploit module used for receiving connections specifically from Android devices. He chooses number 3. Let's set the L host to the IP of the attacker machine on the ETH0 interface. Leo runs the module. He has just opened a door on his attacker machine. The machine is now waiting for Android devices to connect through this door. Once a device connects, Leo will have remote access to it. Next, Leo is going to generate a malicious APK file. He's going to use the same payload, and he's going to configure it so that when Katie installs and runs it on her phone, the phone is going to connect through that door, where this is simply the address of the door. If you notice, the address here is the same as the one here. Why am I calling the APK cool game? I'll get to that in just a moment. One thing that is important to understand is that this technique is not gonna work by itself. Leo is gonna need to use some deception and social engineering to trick Katie into installing the file. His plan is to disguise the malware as a mobile game, and that is where this name is coming from. To deliver the fake game to Katie, Leo has prepared an example website. Here is the source. As you can see, these buttons here are linking to the URL of the website /files/coolgame.apk. So let's create this directory and move our Trojan game APK inside of it. Now our web server directory has the following structure. We have index.html, which is the source of the website. We have a files directory, and inside of it we have the malicious APK. So the plan is simple. A user visits the website, clicks the button, and the button downloads the APK from the files web directory. With that, Leo's delivery web server setup is ready. He runs a Python HTTP server to host it. Now he comes up with a story to trick Katie. Guys, I just want to take an extra second to remind you. In this demo scenario, Leo has Katie's permissions to perform testing. Unauthorized social engineering and hacking is illegal. Please don't try and do stupid stuff. Thank you. She is convinced. She opens the link and hits download. She ignores all warnings and installs the application. Remember the door that Leo opened to wait for the connection? Well, it is still open. Watch both sides of the screen as Katie runs the application. Leo now has remote connection of Katie's phone. Now on her side nothing runs, but that could easily be replaced with an actual game that runs while this session exists in the background. On the other hand, Leo is now able to execute commands, check through her contacts. They were dumped in a file. If we list the local files, here is the file, and we can cut it. He could also dump her SMS messages, also eavesdrop her microphone, watch through her cameras, and so much more. You can find all the commands you can run with help. We have geolocation, we can dump the call log, play sound on the target system, take screenshots. As you see, this doesn't work because the quote-unquote game that we ran isn't a real game and it closed already, but had it been running we would be able to see it. We also have some networking commands, we can upload files and a lot more. Unfortunately, because this is an emulated phone, I cannot demo some of these to you. Feel free to play around for yourself. So that was the exploit, guys. Now, how do you fight against this and defend yourself? Well, it's actually very simple. Never ever install mobile applications from anywhere except the Play Store or App Store. Even when installing less known apps from the trusted stores, do your due diligence before that. If you see warnings like the ones in the video, never proceed. Additionally, on newer Android versions, especially Android 14 and above, this type of attack is much harder due to stricter permission and component restrictions. In fact, this demo was done on Android 13, where these protections are weaker, so using the latest Android version is a good security practice as well. In any case, that's gonna be the end of the video. See you next time.